Assalamualaikum, my name is Muhammad SAFWAN bin AHRAS. So today we will be present about the flood routine and risk assessment for a specific region in Malaysia. So our group member is ADILAH binti SORBANI, MUSTAFE ABDIRAHMAN OMAR, and HAFIZ bin MOKHTAR. So for our introduction is in a recent year, Malaysia has confronted in a mounting threat from recurrent and severe flood, prompting the urgent need for a comprehensive assessment and mitigation strategy. So as we know, in Malaysia we have problem of a flood in year to year, which is because of a geometrical factor in Malaysia. So next, the hydrological study. We have three hydrological study. Firstly is a rainfall pattern, river flow characteristic, and land use and human impact. So for the rainfall pattern, it means distribution of the rain geometrical, temporally, and seasonally. So in Malaysia, as we know, we have two monsoon season. The firstly is the southwest monsoon, and the secondly is north-west monsoon. For the river flow characteristic is ensuring a system can be dynamically approximated based on the long channel balance of the tidal. So the lastly is land use and human impact. So for the land use and human impact is like urbanization, deforestation, and change in land use can significantly impact the hydrological of region. So for the next part, I will pass to our group member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mustafa and today I'm presenting my part of this presentation, which is mitigation design and cost benefit analysis. So the first of, we have to know the term mitigation design. Mitigation design involves the planning and implementing of measures to reduce or prevent the impact of flooding on communities and in infrastructure. This comprehensive approach aims to minimize the effect of flooding through both structural and non-structural measures. So structural measures include levees and embankments. Both of these are important components of flood control system, which provides the line of defense against the destructive impacts of floods and helping to safeguard communities and infrastructure from water-related disasters. Retention basin and determined ponds. These two are stormwater management facilities designed to control and manage the quantity and the quality of stormwater runoff. Flood barriers and gates. These are designed to protect areas at risk from flooding by stopping or regulating the flow of water during flood events. For example, permanent barriers and temporary barriers. Channelization and river training. Dams and reservoirs. These help manage water flow and reduce water risk. Their effectiveness depends on proper design, operation, and maintenance. So on the other hand, we have non-structural measures. Number one, land use planning and zoning. In both urban and rural areas, land use planning are essential tools for control and reducing the risk of flooding. Early warning system. These are really important because they provide timely and accurate information to communities and authorities to take preventive action and minimize the impacts of floods. Community education and awareness. Raising awareness and educating the public about flood risk can enable people to take preventive action, improve preparedness, and reduce the effects of flooding. insurance program is green in infrastructure, rainwater harvesting, and lastly, building design standards are also used to reduce flood risk. So, cost-benefit analysis includes comprehensive evaluation framework. CBA is really important. It's really important for assessing the economic viability of a project or policy. It involves systemically analyzing the costs and benefits.
Okay, my part is catchment analysis and hydraulic modeling. Okay, first I want to explain about catchment analysis. Analyze flood risk in Malaysia involve understanding the catchment characteristics that contribute to flood generation. Catchment analysis is crucial in assessing the factor that influence the intensity and frequency of flood. There are some key aspects to consider using hydrological principles. First, topography. Malaysia diverse topography plays a significant role in flood generation. Steep slope and mountain terrain can lead to rapid runoff during heavy rainfall events. Conduct a topography analysis to identify areas with the high slope may contribute to increase runoff. Okay, second, land use and land cover. Urbanization and change in land use can alter nature drainage pattern, leading to increased surface runoff. Second, analyze land cover data to identify areas with the high improved surface, such as urban area, with may contribute to faster runoff. Okay, the third, soil characteristic. Different soil have very infiltration capacity, affecting the amount of water that can absorb into the ground. Okay, now second, access to soil properties, including porosity and permeability, to understand how quickly water can infiltrate into the soil. Okay, number 4, hydrological modeling. Use hydrological modeling to simulate simulate rainfall runoff process with the catchment. Model like the soil and water assessment tool or hydrological simulation program can help simulate the movement of water through the catchment. Number 5, rainfall pattern. Analyze historical rainfall data to understand the typical pattern of precipitation in the region. Intensity intense rainfall event that may lead to increased runoff, and consider the variable of rainfall, including seasonal pattern of and the occurrence of extreme event. Number 6, river network and drainage pattern. The river network and drainage pattern to identify areas prone to flooding. The efficiency of the drainage network influence how quickly water is transported downstream. Can access the capacity of river can channel and accumulate increased water flow during rainfall. Number 7, land slope and channel morphology. Evaluate the slope of the land and the morphology. River channel steeper slope and narrow channel can accelerate water flow, contributing increased flood risk. And the last one is human activity and infrastructure. Can identify human activity such as deforestation, construction, and dam operation that may impact the catchment hydrological characteristic. Second, consider the influence of infrastructure on water flow, such as a dam, reservoir, and stormwater management system. And topography data exchange the precision of flood simulation by accounting from factors such as elevation change, land use, nature factor that influence the flow of water. Number 4, scenario analysis. Hydraulic model can be used to simulate different flood scenario based on rainfall intensity and duration and others. Through scenario analysis, authorities can assess the potential impact of different flood events and develop strategy to mitigate risk effectively. 5. Risk assessment and management. Hydraulic modeling with risk assessment methodologies allow for the identification of vulnerable area and critical infrastructure. By understanding flood risk, authorities can implement target flood management strategy, including the construction of least or the development of early warning system. And the last one is community service awareness and preparedness. Result of hydraulic model can be used to educate and raise risk awareness among community living in flood-prone areas. And by understanding the potential risk, communities can be better prepared through development and evacuation plans, construction of resilient infrastructure, and adoption of flood-resistant building practice. The conclusion is the integration of open channel flow principle, computation, flood dynamic, and topography data in hydraulic modeling from the comprehensive approach to assess and manage risk in Malaysia. This proactive approach is current in developing effective strategy to the impact of flood on community and infrastructure. Thank you.
Okay, now we're going to do our design flood measure. The first one is going to do what happened. What will happen when a flood going to our area. The first one is we're going to survey our natural disaster. That is, the natural disaster is a natural process of phenomena that may cause a loss of life, injury, and other health impact, property damage, and loss of livelihood and service, social and economic disruption, and environment damage. Next, we're going to do our flood disaster. The flood disaster is the overflow of water which is submerged land that is usually dry. Flood can happen in multitude of ways. The first one is when a river overflow from their bank due to the excessive river or a departure dam upstream and typhoon. Flood often cause damage to home and business if they are located with the flood zone of or our floodplain. In Malaysia, monsoon flood is the famous one. And then we go into the flood mitigation. That is the prevention of mitigation of flood can be studied on their level, introduction properties, small community, and who tour our city. Flood mitigation involve the management and control of flood water of movement due to the rainfall event. The mitigation flood is first we must identify the location of floodplain and the design of the floodplain, the frequency. And then for the floodplain, as you can see on the picture behind, there's a floodplain is an area of land adjacent to the river with strength from the river bank to the base of the crossing valley wall, especially flood during a period of high river flow due to the heavy rain. And then we're going to do our floodplain design. That is, we're going to see how the repeated of the flood in our area. the survey we're going to do is the 100-year return period of floodplain in the land of the prediction to flood during a 100-year rainfall, which is 1% chance to occurring in any given year. A return period is also known as a recurrent interval in a estimate of the likelihood of a flood event occur that we can calculate from our data. That is, return period of year is equal by 1 over annual acceptance probability, or we're going to do annual extended probability in percent equals to 1 per return period of year. So this is the level that we get. And then okay, next this is the 100-year pre-development floodplain. That is nothing that I think that human innovate this area. And then we're going to the 100-year post-development floodplain. We can see the floodplain limits increase around 50% from the basic area. To the flood mitigation structure measure, the structure flood mitigation 100-year return period design is where physical structure are continued to reduce the impact of flooding. Constitutional method leave additional channel. Given the technology report safe green roof, rain garden, thermal paving. Okay, next we're going to see our leaf, that is our river plain. The first one is low tide that we picture in above, and then the high tide that the lower is above the river plain, and then the river that we extend the area to protect the land from flooding. And then this is the picture of the slope. Okay, we're going to do our flood mitigation. It's non-structure measure. Land use planning control strategy. Land use planning will be identify the extent of flood expected land of limit the construction of urban and rural residential, commercial and industrial land. Next, we're going to do a yearly warning system. That is, yearly warning system the extremely important in flooding event to prevent residential with the ability of response impeding the flood water. So for the river basin flood modeling, maintaining the up-to-date flood modern to developing river bank, then to assist the stakeholder of the stakeholder to understand the impact of new development on existing resident in the river bank. Next is a flood risk map. That is the most effective way of reduction the risk to the people to property is through the production of flood risk map. Most of the country have a product map which is show area to flooding based on history, flood and rainfall data. Okay, this is the sample of flood risk map Selangor River and then the one is Selangor River in 2030 that we get that we can see. Next one is the Selangor River Band that we can see the map. Okay, now we're going to do the impact of climate change because we can see from the 100 years of flood is no longer, because it become 10 years flood, and then 500 flood we no longer stay in 500. It maybe become 100 flood now. It's because before climate change, the 100-year flood that was expected to occur once in a year, actually it was due a very heavy rain in occurred only once in 100 years was normal. After a climate change, it might cause more frequency, become abnormal. Let's say 10 year instead of 100 year. So now the 100 year 1% of probability to occur flood has become 10 years 10% probability to occur a flood. And then, but do not forget they have the same level of flight, 40 feet, just different frequency. 100 year become 100 year versus 10 years, or probability that we get is 1%, 10%. So what will be the new 100 year flight after climate change much higher? This is possible because the new 10 years flight is already occur to the old 100 years flight. The new 100 flight now could be equivalent to the 500 years for the 0.2% probability to occur. Okay, now we're going to do the sustainability or resilience, that is today. Okay, now stability is definition is referred to the ability to meet the need of prevent without compromising an ability of future generation to meet their own needs. It involves a balancing economic, social and environment considered to ensure the development in both valuable in short term and does not deplete resources or harm the planet for long term. So the resilience is definition the ability of system that community to absorb shock, adapt to changing condition, and recover quickly for disruption. It involves building the capacity to withstand and become back from adverse event, whether they are environment, economic or social or in nature. So the interconnection of the two things is sustainability and resilience are interconnected concept. Sustainable system is often more realized because it consider long-term impact and stream to create robust and adaptive structure. Conversely, building resilience often involve sustainable practice. For example, community that impact sustainable resource management are better positioned to withstand environment change. So the application that we can see is environmental sustainability focused on the practice that reduce carbon footprint, promote renewable energy, and promote ecosystem. Social sustainability involve social justice, equal and inclusivity to create realized community. The economic sustainability, responsible business practice for fair trade and including economic development. In summary, that we get is sustainability is sustainability and resilience are complementary concept that are extensional for creating a world that can meet the need of present without compromising the ability of future generation to do same, while also they be able to adapt and recover from challenge. Okay, now in conclusion, the flight routing and risk assessment conducted for the specific region is Malaysia provide invaluable insight into the hydrological dynamic and vulnerability of the area through the meticulous analysis and rainfall pattern, river flow categorized, and the assessment of potential impact on population density is infrastructure. This comprehensive study lay the fundamental for effective flood mitigation measure, the integration of both structure and non-structure approach in comparative sustainable and realized design principle is essential for enhancing the region realized for flooding event by furthering community engagement, implementing adaptive infrastructure and aligning structure with climate resilience practice to the outcome of this achievement, not only contribution in immediate risk conduction but also pay the way to long-term sustainability and preparedness in the face of for involving the environmental condition. Okay, that's for our group. Thank you.